Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at another work problem. This one's slightly more complicated than the last two we went over. So without any further ado, let's get straight into it. The prompt reads, in the figure, a constant external force P is equal to 160 newtons is applied to a 20 kilogram box which is on a rough horizontal surface. While the force pushes the box a distance of 8 meters, the speed changes from 0.5 meters per second to 2.6 meters per second. The work done by friction during this process is closest to, and then we have our 5 multiple choice options right here. So, let's just get a few basic concepts out of the way. We know that work is force times displacement. We're given in the prompts that our displacement is 8 meters. And when we're referring to force, we know that of course is going to be the frictional force, since it's asking for the work done by friction. So we're going to have our frictional force times 8. Now, the tricky part here is obviously going to be getting the frictional force. And the first thing we're going to want to do is to draw a free body diagram. So we know that we have our gravity acting down on the block. We have the force P acting on the block. Sorry, let me redraw that in a better way. We have our force P acting on the block this way. We have friction. It's going to be going this way since the block's going to be sliding this way. And finally, we have our normal force, which is going to be going upwards. Now, we know that the block isn't going up or down, so the direction we're going to be focusing on is the x direction, because we're looking at how the frictional force affects the block during its travel of 8 meters diagonally. So let's write out our net force equation in the x direction. And we see here that we have two forces that are acting on the block in the x direction. We have the horizontal component of P, which is going to be P cosine theta, because as we can see here, we have an angle theta. And we know that angle is 30 degrees. And as we can see here is our adjacent. Our hypotenuse is simply P. So the force is going to be P cos 30 degrees. And in the opposite direction, we have our frictional force. So it's going to be, our net force is going to be P cosine 30 degrees minus frictional force. Now, we know that our net force equation is simply mass times acceleration. So let's rewrite it as such. And from here, since we don't know our frictional force, what we're going to have to do is solve for acceleration, so we only have one variable. Taking a look at the prompt, it gives us an initial velocity and a final velocity. However, we're not given a time, but luckily we are given a distance, and that is what makes this problem possible, because we can use our kinematic equation that uses distance, and that one's going to be v final squared is v initial squared plus 2 acceleration times distance. Now, we have all of our values here except for the acceleration, so we can solve for the acceleration of the block. So let's pull out our calculators so we can find 2.6 squared. Alright, using two sig figs, we get a value of around 6.8. We know that our v initial squared is 0.5 squared, which will simply be 0.25. and that will be equal, and then we get that 6.8 is equal to 0.25 plus 2AD. Now let's subtract our 0.25 from both sides. Get that 6.55 divided by 2 is equal to AD. All I did here was divide both sides by 2 after subtracting. We know that our distance is 8 meters, so that gives us an acceleration of 6.55 over 16 because we divided both sides by the distance. So now let's calculate this value. 6.55 divided by 16. That gives us a value of roughly 4.1. Or sorry, rather 0.41. A equals 0.41. And from here, let's go back to our original equation, our net force equation. We had MA is equal to P cos 30 minus FF. Now from here, we have all of the variables necessary to solve this equation. Our M is given to us as 20 kilograms. Our A is 0.41. P total is 160. Cosine of 30 degrees is going to be root 3 over 2. So we get 80 root 3 by multiplying 160 by root 3 over 2. Is equal to the frictional force. So now let's do these calculations to get our value of frictional force. 20 times 0.41 is going to give us 8.2. We're going to subtract 80.3, or 80 root 3 rather, and that'll be negative frictional force. Alright, and that gives us a frictional force of around negative 128 newtons. Now that we've done all the calculations, we know we need to go back to our original work equation. Or sorry, the force is going to be positive because the negatives cancel, so it's just going to be 128 newtons. So we have FD. We remembered that our distance is simply 8 meters. Our force is 128 newtons. So we'll have 128 times 8, which will give us our final answer of 1,024. Now, we must incorporate a negative sign here, and the reason for this is that friction is going in the opposite direction that the block is moving, and since the frictional force and the movement of the block form a 180-degree angle, we know that our full work equation is FD cos theta, and the cosine of 180 degrees is just -1, and that's where the negative sign comes from. This will be your final answer. We see that there's no answer quite like this, but we can account for gravity for this minor discrepancy, and we pick D as our final answer as it seems like the closest option. And of course, I went over this problem before creating this video, and D is the correct answer. And keep in mind that using a gravitational value of 10 will be accepted by most physics teachers and by the College Board, so there are no issues with using this method. And that's all I have for you guys today. Make sure to stay tuned for more physics tutorials, and yeah, that's it.